Hey, welcome to the Art of Code. My name is Martijn, and what you see behind me here is a Bezier curve. And Bezier curves are used all throughout computer graphics and also all throughout engineering. And so it's very good to know how they work and how you can construct one yourself from scratch. So that's what I'm going to do in this video. If that interests you, then let's do this. Alright, so let me make a new shader and go directly or completely from scratch. This, by the way, is a website called ShaderToy. You can just go shadertoy.com. You can follow right along. For the concept of Bezier curves, they're used all throughout all kinds of softwares, and you can implement them in your own software of choice. I'm doing this just in ShaderToy because it's a fun website that I use a lot, and that you can just go to and code right along. So I think that's very valuable, and it allows you to learn a lot. So I highly recommend going to shadertoy.com, making an account, and following along. So all right, so we start here with the standard shader. Let's first clean up a little bit. Let's make a black screen. By the way, this video is not about shader coding. My channel in general has a lot to do with shader coding. If you want to learn about that, then check out some of my other videos. I'll put some links in the description. But even though I do this in ShaderToy, this has very little to do with shader coding. This is just about the Bezier interpolation. All right, so I have a black screen here. Let me just make sure that my UV coordinates are in the middle. So -I resolution.xy times 0.5. This is just to make sure that my origin of my UV coordinates is in the middle, and that's aspect ratio corrected. So let me just get rid of that as well. Now the first thing I'm going to do is I'm going to write a little function to draw a circle. So for that, I'm going to go over here. I'm going to say float circle, and it takes as an input a 2D position P, and then also a center of the circle. And I'm not even going to deal with radius. I'm just going to hard code that in because this is more to show what we're doing. So to draw a circle, what you need is you need to calculate a distance from the center of the circle. So that's P minus C. So that's just the distance from the center of the circle, and then I can return a smooth step of I'm going to use an F width to make it nice anti-aliased. And then I'm going to do that. I'm going to do D minus 0.03. Let's see what that looks like. So let's see if that compiles. That compiles. So now let's see if we can draw a circle. Col plus equals circle of UV, and let's just do it in the middle. Let's see what that looks like. Okay, so that's a dot. Let's make a dot a little bit smaller. Okay, so that's fine. All right, and I'm also going to make a function that can write a line, or that can draw a line. So for that, I'm going to go do the same thing, float line, and a line has as an input a position that we want to evaluate, and then an endpoint A and an endpoint B. And now we have to make some vectors. Vec2 PA, which is P minus A, and BA, which is B minus A. And then we're going to make a variable T. That T variable is the clamped version of the dot product of PA and BA divided by the dot product of BA and itself, 0 and 1. And now that we have our T value, we can calculate a point that's on the line that goes through A and B, that is closest to point P, which is, let's call that point C. And point C is just you start at A and then you go in the direction of BA for T steps. And then I can return the smooth step of yeah, if I want to do that, then I have to do this. So float D equals the length of C minus P, and then I can do the same F width trick here, so I can do that and 0, and then D minus the thickness of the line. So let's make it maybe even thinner. Let's see what that looks like. All right, so that compiles, and let's see if we can draw a line. Col plus equals line of UV, comma, let's make this line go from minus 0.5, comma, minus 0.5 to 0.5. So that would be this. And over here I could do the same thing, right? If both of the x and the y are the same, then you can just do it like that. Let's see what that does. Okay, so that creates me a line. I just have to make sure that that's actually a line segment and not a line. So let me just make this a bit smaller. Okay, so there you have a line as well. All right, great. All right, so now let me just make these a little bit smaller. And now let's get started with this Bezier stuff. So yeah, let's first make the endpoints of our Bezier line. So for the endpoints, I'm going to call them A, and A is the first endpoint, which let's say minus 0.5, comma, minus 0.4, and B is on the other side, right? So let's say 0.7 and also 0.4. Okay, and now I'm going to draw point A as a red point. So col plus equals, first I just draw the color. So the color would be, for red it would be 1, 0, 0, and then times this circle of UV and point A, right? So let's see if that works. Okay, I don't see anything. It might be because it's too far out. Let me see here. Okay, so there it is. So let me just stick it out a little bit on the corner. Yeah, something like that. And now I'm going to do the same thing for my point B, right? So my point B is going to be blue. So that's 0 in the red, 0 in the green, and 1 in the blue channel. And then I have to do this, and it's going to be out of the screen the same way as what I had here. So let me just do that. No. Okay, there we go. I guess we can't see a whole lot here. It's kind of small. All right, so those are the endpoints. Now I'm going to make a third point, and that is a point that that is going to be the control point for the Bezier, so that you can control the shape of it. So sometimes when there's multiple declarations, I like to just do it like this. It's a bit cleaner. So I'm going to call this C, and C is going to be a point that comes from the mouse. And so for the mouse, I can just use the same as what I did over here, but instead of frag chord, I'm going to throw the mouse in there. So let me just copy this. Control C, Control V, get rid of the extra semicolon, and then here I say iMouse.xy. All right, and then I can draw that as a green point. So green would be 0, 1, 0, and then C. Okay, and now I have a point that follows the mouse. If you click the mouse inside of the viewport, you have this point. All right, so now how do we make this Bezier? Well, what we have to do is a Bezier is constructed by using a bunch of linear interpolations but stacked on top of each other. And so the first thing that I want to do in order to see this better is to just draw a line between all these points. So let me do that. So let me do call plus equals line of UV, and then first I'm going to do from A to C, right, from the red to the green, and then right away I can also do it from C to B, and that should do that. Perfect. All right, so now yeah, this actually, so in the case of a quadratic Bezier, which is what we're building right now, which is the simplest Bezier that you can make, you have both of the tangent lines of the final curve are these lines. So the curve that's going to go out of the red point is going to have this tangent line, but then obviously it's going to curve, and then in the end it's going to have the other tangent line. So these are two tangents that are controlled by one point. So how can we do that? Well, first we want to construct another point that is on this line, and then also one that's on that line. So how do we do that? Well, I can make a point here. Let me where can I best show that? Yeah, over here. Let me make a point that is halfway between A and C. Let me just call it AC, and AC is or halfway or anywhere in between. So I can use a mix function for that. So I can mix between A and C, and then I can use I can have some value between 0 and 1 here in order to interpolate between those. And let's visualize that. So let's take this color here, let's copy it, and here that's halfway between the red and the green one, so I'm going to do it full red and full green, which is going to be yellow, and then AC, and let's see what that looks like. Okay, so now we have a yellow point that's always halfway between the other two points. But the cool thing is here I can change this to if I have it at 0, then it's all the way at A, and as this gets larger, I just slide from A to B, right? And I can do that automatically so that we can see what's going on. So let's just make a value t, and that value t can just be anything, right? Like that. But the reason why I do it like this is so that I can animate it. So I want this to animate between 0 and 1, so I can use a sine for that, and just throw the time into it, and the sine goes from -1 to 1, right? So we have to convert that, we have to push that into the 0 to 1 range, and the way to do that is by multiplying by 0.5. So now it goes from -0.5 to +0.5, and now we just shift it up by 0.5, so like that, and then we have a value that animates between these two. Okay, great. So now let's do the same thing for the point that is between the middle and the blue point. So that would be, I guess we would call that CB equals mix of C and B and T. And then let's throw that one in here as well, like that. And that one is half green and half blue, so that would be teal or cyan, CB. Okay, so now we have a point there as well. Okay, and now what I'm going to do is I'm going to draw a line between the yellow and the cyan point. So for that, I could just go over here, say call plus equals the line of UV, and then we're going to do AC and CB. And let's see what that looks like. Okay, so now we have that line. And now I'm going to do this sliding on a line segment business one more time on the line segment that we just created. So I'm going to make a third point that slides between the yellow and the cyan point. All right. So for that, I'm just going to go over here, and what can we call it? I guess well, ACB, I suppose. And that's a mix of AC and CB with T. Okay, and now let's add that point over here, and let's make it white. And so ACB. Okay, and now we have that white point, and the white point is following a quadratic Bezier curve, which is pretty cool. So you can see how if you want to animate things, for instance, then this is very, very powerful, right? Like if we just get rid of all the other points. So let me just do that real quick. Let me just get rid of the guidelines as well. So get rid of the guidelines and get rid of, I suppose, all the other points. So well, not A and B, because we want to see that. And I guess also we want to see the control point as well. So like that. So yeah, if you want to animate anything, then this is very powerful, because it gives you full control over how the animation goes, right? You could even have it that it goes back a little bit in the end, you know, stuff like that. So yeah, so this is very powerful. This is used all throughout computer graphics and engineering as well. All right, but how can we draw a line or a curve, like draw the actual curve? So let's try to do that. And so what I'm going to do for the curve is I'm going to make a loop with that kind of steps through different points on the curve, and then for every new point that we calculate, we just draw a line from the previous point to that point. Okay, so this is kind of a segmented solution to this. There is also an analytic solution to a quadratic Bezier, but that's not what this video is about. I'll probably do a future video about that. So for now, we're just going to approximate the curve by a bunch of straight line segments. All right, so for that, I'm going to go over here, and first I'm going to define a number of line segments. So num segs equals, let's say, 25, and then I'm going to make a for loop. So I'm going to say for int I equals, and I'm going to start that loop at 1. So normally you start a loop at 0 often, but I'm going to start it at 1. And you'll see why that is in a moment. And then I have to say I smaller than or equals to num segs, and then I plus plus. Let me just put some space at the bottom so this comes in the middle. All right. Okay. And so now inside of here, we need to evaluate the Bezier for different values of t, right? So because this whole Bezier thing was kind of fed by a value, by a t value, right? That goes from 0 to 1. And so we need to do that here. We need to evaluate the Bezier at different points. And so like the cleaner thing would be to take this and to put this in its own function. So let's do that. So let me make a function that returns a point in 2D space and call it Bezier. And the Bezier has as an input an endpoint A, an endpoint B, and a control point C. And also it has that t value, because we need to know where on the curve we need to evaluate this. And now inside of here, it's actually very simple. I could just return, well, what were we doing there? Well, first we're interpolating between A and C, right? A, C with T. And the second we were interpolating between C and B with the T value. And then the result of that was interpolated as well, right? So also with the T value. So this is the entire Bezier interpolation on one line, which is kind of neat. All right, so now we have the Bezier interpolation over there. So now we need to do a few things. So for every step, I'm going to draw a line between the new Bezier point and the previous point, right? So we need to keep track of what those points are. So for the new point, I'm going to call it capital P. For the old point, I'm going to call it previous point, PP. And the previous point, because on the first time we get into the loop, we don't have the previous point, so we have to interpolate, we have to initialize it, and I'm going to initialize it at the red point, right? So the red point is point A. All right, and so now that we're inside of here, we need to calculate a T value. So this loop is gonna go through each step, and for each step we want that. So we want the T value to start at, let's say, 0, and then at each step it goes one step along the curve until like in the end it's at 1, right? So for that I'm going to say T equals, and what I can do here is I can say it's just I divided by numsegs. All right, because I in the beginning it starts at 1, so it's 1 divided by 25, so it's 1/25. That's my first step, because I don't want to start at 0 because I need already 2 points to draw my first line. That's why I'm starting at 1. And then as I goes on, it goes towards 25, right? So in the end you get 25 divided by 25, which is 1. So this makes it that T goes from 0 to 1. Now the only thing is that both numseg and I are integers, and if you divide integers then you can only get an integer, but we want a float, so we have to cast these two floats before we do that division. So I have to do that. So this will make T go from, not from 0, but from 1 over numseg, really. Well, from almost 0 to 1. Okay, I hope you understand like that in the beginning T is not 0 because I is already 1 to begin with. So it starts at 1/25 basically. Anyways, so now we can calculate the point, because we can just throw in here A and B and C with the T value that we just calculated, and now we draw a line between this point P and the previous point PP. So col plus equals line of UV and P and PP, like that. And then at the end of the loop we have to make sure that our previous point is updated. So PP, our previous point, is our current point. Now let's see what that looks like. And look at that. Now we have a beautiful curve. Awesome. One tiny thing here, where these line segments touch, it's slightly brighter. And that is because I'm just doing a simple add here. And so where the anti-aliased edges of the line overlap, you get it brighter. And if you don't want that, then you can also use a max function. And the max function just makes sure that it cannot get, like, it doesn't work additive. It just takes the largest value of both. And it's maybe hard to see on the video, but if I compile it now, it's going to look nicer. It's going to take those issues away. All right, well, that's pretty much what a quadratic Bezier curve is and how you generate it. I hope you got something out of it. So now this is like the simplest Bezier curve that you could make. It's quadratic, so it's based on a polynomial. Like it's basically based on a parabola. So really, like what you're doing here is you're very cleverly constructing part of a parabola to do this movement. And I would say for many things this is perfectly adequate. If you want to get more fancy, you can get more fancy. One way that you can really understand, and how I understood Bezier, was going to the Wikipedia page on Bezier Interpolations, and they have some really good animations there that really make it clear what's going on. So basically we're just building a tower. Here we're just building a tower of interpolated points, right? So you generate an interpolated point, and you do that for all line segments, and then you generate interpolated points between the interpolated points. And so the quadratic Bezier is just the smallest tower that you can build, but you can make cubic Beziers. Cubic Beziers are kind of handy because they have two tangents that are independent of each other. So instead of having one point that controls both the tangents of the red and the blue, with the cubic Bezier you have a tangent that's just completely independent of the other one. And then you can get fancier than that. So, but unless you're making satellite guidance systems and whatnot, I guess you don't really need that. Anyways, that's a lot of waffling about Bezier curves, but yeah, that's how you make one. If you make something cool with it, be sure to share it, and I will see you next time.